Welcome back to the video lecture series on engineering mechanics. Today in this video, we will try to learn Lami's theorem. The overview of today's lecture is, before going to understand Lami's theorem, first let us try to understand the converse of triangle law and polygon law. The Lami's theorem uses converse of triangle law. That's why first learn converse of triangle law and then go to Lami's theorem. At the end, apply Lami's theorem to solve a problem in engineering mechanics. Converse of triangle law and polygon law. Let us see converse of triangle law. The converse of triangle law states that if three forces acting at a point are in equilibrium, then they can be represented in magnitude as well as direction by the three sides of a triangle taken in order. Let us see, if three forces acting at a point, the three forces are P, Q and R. Now, the body is under equilibrium by the action of these three forces. The converse of triangle law of forces states that if three forces acting at a point are in equilibrium, then they can be represented in magnitude and direction by the three sides of the triangle taken in order. We can understand the same statement in another way. If a body is under equilibrium by the action of three concurrent forces like this, then if you try to draw the force polygon, that is force polygon P, Q taken in order, P, Q and R, see, closing side of the polygon, in opposite order gives us the resultant. This is what the polygon law of forces states, that if three forces acting on the body, are taken in order like this, P, Q and R, and the closing side of the polygon will represent the resultant. But here the three forces are under equilibrium. The body is under equilibrium. That means the resultant is equal to 0. The last side will come and join with the first point. That's why we will get a triangle. Instead of a polygon, we will get a triangle, because the resultant is 0. When the body is under equilibrium, the resultant is 0. Right. Now, look at the force polygon. Here, AB is representing the force P and BC is representing the force Q, both in magnitude and direction. Then, R is representing the force CA is representing the force R, both in magnitude and direction. Instead of a polygon, we will get a triangle, closed triangle. That is what the converse of triangle law says. Next, converse of polygon law. When four forces acting on the body, let us say, if four forces acting on the body, P, Q, R and S, if four forces acting on the body, if you try to draw the force polygon, see, P, Q, R, S. The closing side of the polygon in opposite order, actually it should give our resultant of these four forces. But when the body is under equilibrium, it will get a closed polygon. This is what the converse of polygon law. Let us look at the diagram for this these forces. See, P is represented by AB in both magnitude and direction. Q is represented by BC and R is represented by CD. And then, because the body is under equilibrium by the action of these four forces, right, the closing side, there will be no closing side. The last side will come and join with the first point, right. So, any number of forces acting at a point be represented in magnitude and direction by the closed polygon taken in order when the forces are in under equilibrium. So this is what converse of polygon law. The takeaway what we are taking from the converse of triangle law and polygon law is, when the body is under equilibrium by the action of three concurrent forces, we'll get a closed triangle. If the body is under equilibrium by the action of more than three forces, we'll get a closed polygon. With this takeaway, let us move on to understand Lami's equation or Lami's theorem. Lami's theorem states that if a body is under equilibrium by the action of three concurrent forces, then the force, each force is proportional to the sine of angle between other two forces. This is the property of the triangle actually. If a triangle is taken like this, so this is P, the length of P is proportional to opposite angle. If the angle is increased, P also increases. Similarly, this is Q, the length of Q is proportional to angle between P and R, other two, that is opposite angle. Right. See, each side is proportional to angle between other two, or each side is proportional to the opposite angle. So this is the property of the triangle. By using this property of the triangle, Lami derived an equation which we can apply to the equilibrium of the forces. And this Lami's theorem is applicable only when three forces are acting, and the three forces must be concurrent, and the body should be under equilibrium. Then if three forces are acting and all the three forces are concurrent forces and the body is under equilibrium, what shape we will get if we try to draw force polygon? We will get a closed triangle. So that's why the property of triangle we can apply to the forces. Let us understand PQR be the three forces acting on the body along the directions as shown in figure. Right. Now draw the force polygon. The body is under equilibrium and all the three forces are concurrent. Now draw the force polygon. We'll get a closed triangle. Right. The angle between Q and R is alpha. The angle between P and R is given as beta, and finally the angle between P and Q is given as gamma. Now try to draw the force polygon. AB is representing the force P in both magnitude and direction. Now Q is making an angle of gamma with P. So draw a line making angle gamma and then cut with the same length as Q by taking some scale, and then draw another line which is making an angle alpha with the line Q, and draw the line which is representing the force R. Finally, we will get a closed triangle because these three forces are making the body or keeping the body under equilibrium. So we will get a closed triangle. If it is not joined to the last point is not joined to the first point here, so that we will get a resultant. If the resultant is there, the body is not said to be under equilibrium. If the body is said to be under equilibrium, resultant equals 0. That's why the last force will come and join with the first point. Now let us see the angles here. Right. The angle between the forces Q and R is 180 minus alpha. The angle between R and P is 180 minus beta, and the angle between Q and P is 180 minus gamma. Now each side is proportional to sine of angle between other two forces. See here, P is proportional to sine of angle between Q and R, that is sine of 180 minus alpha, and Q is proportional to angle between other two forces. Q is proportional to opposite angle. This is proportional to 180 minus beta, and R is proportional to 180 minus gamma. So, by using the property of the triangle or sine rule which is applied to the triangle, that is AB, the length AB divided by sine of 180 minus alpha. AB is proportional to 180 minus alpha. So, here this is the sine rule which is the property of the triangle which can be applied to the triangles. So, AB divided by sine 180 minus alpha is equal to BC divided by sine 180 minus beta, and CA divided by sine 180 minus gamma. So, this is the sine rule. Now, AB is representing P and BC is representing the force Q and CA is representing the force R. Now, let us replace the lengths of the sides of the triangle with the forces. P by sine alpha, here sine 180 minus alpha equal to sine alpha, sine 180 minus beta equal to sine beta, sine 180 minus gamma is equal to sine gamma. So, finally, the Lami's equation is given by P by sine alpha equal to Q by sine beta is equal to R by sine gamma. Now, let us try to solve a problem by using Lami's theorem. The problem is a machine weighing 5 kilonewtons is supported by two chains attached to the same point on the machine. One chain goes to the hook in the ceiling and has an inclination of 45 degrees with the horizontal. The other goes to the eye bolt in the wall and is inclined at 30 degrees to the horizontal. Make calculation for the tensions induced in the chains. See, the problem diagram is given like this. So, there is a machine component which is weighing 5 kilonewtons, right, and it is supported by two chains BC and AC. Okay, one chain is attached to the eye bolt which is at an angle of 30 degrees to the horizontal, and another chain goes to the ceiling which is at an angle of 45 degrees to the horizontal. Both the angles are given with respect to horizontal. Now, let us draw the free body diagram for this problem. The free body diagram consists of or shows only forces, the support reactions, induced forces, internal forces, self weights, and all external and internal forces. So, here to draw the free body diagram, remove the supports, remove the wall, right. So, the weight of the body always acts vertically downwards, weight of the body is 5 kilonewtons here. Now, remove the supports. If you remove the supports, it is not possible to keep the body in this position. When the supports are there, they are exerting upward forces to keep the body in that equilibrium position. That means the tension in the string, AB is in upward direction. So, the tension in the string is TAC, the tension in the string is TBC, both are acting in upward direction to keep the body under the equilibrium position. Now, draw the force diagram, remove the body and draw only forces. The force diagram for this case is the weight is acting vertically downwards and TAC is at an angle of 30 degrees to the horizontal and TBC is at an angle of 45 degrees to the horizontal. Now, apply Lami's theorem. These three forces, the body is under equilibrium, three forces are acting on the body and the three forces are concurrent. So, we can apply Lami's equation. The Lami's equation is given by P by sine alpha equal to Q by sine beta is equal to R by sine gamma. Here, substitute the values. Take any one as P. Here, let us say W. W by sine 180 minus 30 minus 45. Here, the angle between other two forces. If you consider W is one force, here it is W. In place of P, I am taking weight. So, 5 kilonewtons divided by sine of angle between other two forces. Here, alpha is sine of angle between other two forces. If I consider W, I need to consider the angle between TAC and TBC. The angle between other two forces is See here, the total angle is 180. So here the angle between TAC and TBC is 180 minus 45 minus 30. 180 minus 45 minus 30, or otherwise 180 minus 45 plus 30. 45 plus 30, and if we add 30 and 45 and remove subtract from 180, so that you will get the angle between TAC and TBC. Here it is. And then TAC Q, take any one force, that is TAC divided by angle between other two forces. Here the angle between TBC and W is 90 plus 45. 90 plus 45. Right. Finally, TBC divided by angle between W and TAC. Angle between W and TAC is 90 plus this 30, 120. 90 plus 30, 120. So the final equation is W divided by sine 105. 5 divided by sine 105. TAC divided by sine 135 and TBC divided by sine 120. TBC divided by sine 120. Right. Now take any one part. Take one part of the equation. TAC sine 135 equal to 5 divided by sine 105. From this equation we can get the TAC value. TAC is given as 3.66 kilonewtons. The tension in the string AC or the tension in the chain AC is 3.66 kilonewtons, and similarly TBC is given by TBC by sine 120 equal to 5 divided by sine 105. TBC is equal to 5 divided by sine 105 into sine 120. So from this expression we can get TBC value. This is how we can apply Lami's equation when three concurrent forces acting on the body and the body is under equilibrium. In this video, we have learnt the converse of triangle law and converse of polygon law. We have seen the statement and proof of Lami's equation or Lami's theorem, and we have successfully applied Lami's equation to solve a problem which is under equilibrium by the action of three forces. Thank you.